Good afternoon, Jan.
Michael, good afternoon.
How do you do, sir?
Doing fine. We switched to winter hour meanwhile.
Ah, yes.
Oh, it's only 2 o'clock in the afternoon, not 3.
Yes, I believe that we are going to be switching next week, so it'll be
Okay,
it'll be back to the regular time for you then.
okay. Um, but you stay in UTC on the same time, or you want to switch?
Yeah, I want to switch this time. I believe this is the last time for the United States, so I think after this switch we're gonna stick. Um,
Okay.
so I might have that off by one. It might actually be the next switch in the spring, um,
Mm,
but yeah, don't need to fight that fight anymore.
okay. Well, in Europe, they want to cancel it since since
Mm-hmm.
I think about 10 years ago. And now they have so many other things, so I
Mm-hmm.
think they forgot about
Oh
it.
yeah, yeah. Mexico
Yeah.
has already canceled it. So the folks that I work with in Mexico are yeah, they've just switched this week. So um, so yeah, they're attending stand up an hour earlier. Yeah, and uh, and so yeah, next week. Okay, you'll be back to the regular stand up time. Um, but uh, but yeah, so the U.S. will be on a constant time as well.
Okay. No, the big trouble in Europe, in Western Europe, seems to be that some countries want to be in wintertime and others want to be in summertime. And so
Yeah.
if they are on the same length,
Mm-hmm.
then if,
Yeah.
if if you travel from north to south, you'll be switching all the time.
Mm-hmm.
Uh,
Yeah.
so
I think that's preferable to changing your clocks throughout the year. But yeah, there are already places where the time zone offset is kind of a jagged line going north to south. So um, yeah, I think that'll be
in the
we'll
States, you have
figure
the
it out.
same thing. If you travel from south to north or north to south,
Mm-hmm.
time is changing.
Yeah. Yeah.
Mm,
So we still have the fight of let's just let everybody say what time it is in UTC, um, and then figure out when they're going to eat lunch because that's the only math you have to do.
yeah. Okay.
Yeah,
Yeah.
yeah.
But
In the states they call it Sunshine Protection Act, the Sunshine Protection Act, some ridiculous name like that. Like we're going to protect the sunshine.
uh,
Yeah, that's even more
why not?
ridiculous than we're going to save the daylight.
Mm.
Uh,
As long as they don't combine it with the word tax, it's all right for me.
yeah.
Uh,
Yep. We're saving the sunshine,
good.
and then we're going
Yeah.
to tax it at just 2%.
Yeah. Why
Yeah,
not?
2% for sunshine. Man,
Um,
what a bargain.
yeah. Good. Now it seems like an eternity if we miss one meeting
Yeah, I know.
uh, of historical modeling,
Mm-hmm.
and I really need your help here.
All
Right.
right.
Yeah. Let me make that window a little bit smaller, and then I will share it. Um, which one is it? Oh, all windows are black now. Okay. Oh no. I think it should be. Yeah, it's that one.
All right.
So what I wanted to do. Um, why is this not moving anymore? Doesn't want to move. Okay, never mind. Um, so we had this SQLite branch from long ago
Mm-hmm.
where I introduced SQLite. I never updated that branch. Then I published it to GitHub.
Mm-hmm.
So now I thought it was just working on it again. So I thought it's time to merge with your latest branch. That's very fine, but now my old tests are failing.
Oh. Hmm.
And probably because since end of September, in the when you add facts, it wants them to be in topological order.
Yes.
So you wait, if you go to the graph here, you have here add facts,
Mm-hmm.
and now he's checking whether you can add a fact, and this check is gonna see whether all the predecessors are already into the graph.
Right. Yes.
So the problem is if I load facts from my database, they are in, I think, in whatever order,
That's
and
true.
so the
Yes.
test fails.
Okay. Well,
Um,
there is a solution for that. So at the same time that I added that constraint, I also, or maybe one commit later, I added uh, a fact tree builder, I believe is what it's called. And if you use
yeah,
that instead of directly accessing the fact tree, then it reorders things topologically.
okay. So wait, where is that factory builder here?
Fact graph builder, that's what it's called.
Oh, fact graph. So that should be somewhere here in
Yeah, it's right next to the
Jinaga.
fact graph.
Here.
Yeah. Yep. So you create one of those, and then you repeatedly call
And
add fact on that. Um,
okay.
and so
And so
if it's
that one will, yeah, go
mhm.
ahead.
If it can't add that fact to the graph yet because the
Okay.
predecessors aren't there yet, it puts that fact in reserve, um, which presumably would let you add the predecessor later. That'll get into the graph, and then when you come back and call build, it's going to look to see is there anything in reserve, and then try to add those to the graph. And it's going to repeat through that loop until reserve is empty or until nothing has changed. Um, if nothing has changed, then that means there's a fact in reserve whose predecessors just never made it into the graph. They're nowhere to be found.
Why don't you call this build every time when you add a new fact? So if a new fact gets in and it gets added to the graph
Mm-hmm.
afterwards, so here we could call the build because once you add a new fact, that might be the predecessor for which you are waiting.
Mm-hmm. Yeah, it's just the performance characteristics is, you know, which is really probabilistic in this case. Um, what's the probability that this fact unlocked something in reserve, um, uh, given that you're going to be adding several facts in one go? So do you want to take that hit of checking every time you add a fact, or do you want to wait until the end and try all of them? So I think, and I haven't actually measured this, but I think the performance is better this way. That it waits until you're ready to build, and then um, puts everything through. So the
Okay.
absolute worst case scenario is that you add facts that are in a line from the bottom to the top, and so they all get
Mm-hmm.
into reserve in reverse topological order. And then when
Yeah.
you call build, it goes through the entire list, then adds the last one, and then it goes, it loops through, and then goes through the entire list again as the last one. So in the absolute worst case, it is n squared. But I think probabilistically, this This gives you the fewest um, the fewest times through the list.
And because another solution would be to load them from the database
Mm-hmm.
to make sure that when you save them to the database that they are in topological order. You could load them again from the database in topological order.
Mm-hmm.
And then in communication, you also have to make sure that you that
Yeah.
that you don't send on multiple channels at the same time to keep them in because if as long as you send them nicely serial and you wait until the previous one is arrived before you send the next one,
Mm-hmm.
then you're fine. But would that be
Yeah,
a good solution or
I think so. I think that would increase the probability that you get these in topological order here. Um, I wouldn't want to 100% depend upon that because that moves the constraint. Um, so if you've got the constraint that you have to be able to select them out of the ancestor table in topological order, then that means that now when you're doing concurrent inserts, you have to make sure that those concurrent inserts are topological with one another. Um, and
if they are
yeah,
concurrent, then there is no predecessor, so it doesn't matter.
yeah, they might have a common predecessor. Yeah, so this is the sort of thing. Okay, you have to think through all um, the different scenarios, and just make sure that you've accounted for everything. So so in order to you know um, in order to have confidence that the factor graph has a topological order that you can rely upon, then you have to write those proofs for everything that feeds the graph. Um,
Yeah.
yeah, with this, you don't have to write those proofs, but it's still a good idea to try to make them so. Um, so one simple thing to do would be uh, if you add a monotonically increasing column to the ancestor table, then make that explicitly order by that, um, and maybe even make that the clustered index. Then then um, you can have some confidence that when you pull those out, they will be in topological order. Which means you go through here, nothing will ever hit reserve. You go to build, reserve will be empty. It's the fastest that it possibly could be. But yet, I would still want to use this code just in case.
Yeah. And anyway, if we use that code, if everything is in topological order, there is almost no performance problem,
Right. Yes.
and it's an automatic checking because you might put a breakpoint there for to check if reserve is or even give a warning reserve is not empty anymore. So there is an issue with topological ordering, and that might be a place where you can improve if necessary.
Mm-hmm. Yeah.
Mm.
Yeah. So if you had like another property
Mm.
that you exposed, which just told you if this builder ever put anything into reserve, then you could write a test. Say, okay, I'm going to actually um, hit the database with several different inserts, and then I'm going to load everything, and then check the graphs every time I load. Has anything ever gone into reserve? And then if so, now you've got, oh, okay, here's the case where that is violated. Let me go ahead and fix it. But in the meantime, things still work. The
Okay.
violations make it through in production.
I have to make a fact graph builder, and then I just get it back. Okay, so um, that means because I'm adding that fact there,
Mm-hmm.
um,
Yep. So this is no longer
So
the immutable pattern that you're using here. It's just create a fact graph builder and then for each call add on that same fact graph builder. Um,
yeah,
the graph itself is immutable. It's replacing smaller graphs with bigger graphs. And in fact, the reserved
mm,
list is also immutable. It's replacing smaller lists with
yeah,
bigger lists. But all of that state and all that mutation is kept within the fact graph builder.
builder. That's builder. Um, okay, and then I can just um, yeah, but so here I take my fact graph, right?
Yeah, you won't be able to do that inside of aggregate since aggregate follows the immutable pattern. You'll just want to do a for each.
Unless because I have to build to get the whole thing back.
Yes.
To get the graph back. Um,
Yep. So you just do a for each over your results. You call add with each result, and then after your loop, you call build, and you've got your factor graph.
so we start from, but I had to deserialize that one. Yeah. For each,
One word with the for each.
for each fact. That's a factor. Yeah.
Yeah, and
And,
in C sharp it does the parentheses around the facts from DB.
um,
Yeah, so open parentheses before the fact.
wait, I'm again complete lost.
Yeah,
Ah,
so it's for
yeah.
each and then parentheses.
Oh,
Yeah, so you open parentheses right there. Yep.
yeah.
Not
It's
bracket parentheses.
it's that's
Yeah, now you can do the
for
in.
each, and then my in.
Yeah.
So and then okay, like that.
And why is it not happy about the in?
In
Uh, Maybe I've forgotten my C sharp.
dot
Uh,
deserialize.
oh, okay.
No, no,
Is
still.
it of? Why am I
Wait,
forgetting this?
wait. Type and identifier are both type and
Yeah, it might be for each of. C sharp for each.
no, not that. Uh,
Uh, you are correct. It is in. Why is it complaining about the in? Let's see. Type and oh. Oh, okay. We have to declare fact as var. To put var in front of fact.
and
Yeah, because it.
like
Or the type.
this.
Yeah. Yeah.
I put fact as, but no, it's yeah,
Oh
it's a
my goodness.
mess. So for every fact, what am I gonna do is just add it. So first of all, I have my new fact builder. So make this just Facebook. uh, add my facts.
Mm-hmm.
Um, it's not, yeah, it's doing just that.
Yep.
And then here, my fact graph, and that one is builder like this. Huh?
Call the function
No, it's
parentheses.
yeah. now
Yep.
that should be okay. Let's save that. Let's go back, upload from the store, just run it and see what it does. Yeah, and then the
Yay.
other one should also.
Yep.
All right.
Okay.
And so
So
now we can
yeah.
go to our Git changes. Okay.
And while you're
Just
doing this,
all.
I'm curious. I do see the task from result, which means that we're not awaiting anything async. So is
Which one?
yeah at the when you do the return, you're doing task from result. Um, so that means we're not inside of an async method, and we're not doing anything with await. Is there an async version of execute query?
Wait, what did we? At a certain moment, we said we are not gonna do it asyncly, the load, because what was it? And we were gonna put everything in an async. We were gonna put an async envelope around it. But
Okay.
anyway,
I'll
so
make a
this
note
one
here.
yeah, this one is returning a task. So that was probably why. What was the problem at the time? Remember SQLite was having through the libraries that we used initially could work asyncly, but if we dug into the library, it was not really async. And so in order not to have problems with transactions, we kept it this way. And so in the end, we just use this task from result. I would have to go back and see what I put as comment in GitHub, but I think it was that.
Okay.
Why are we running into trouble with this?
Okay. What? Yeah, I was making notes. I'm not seeing what trouble we're running into, or just why am I concerned about the task from result? My concern is when we start to use this on a mobile device, then this is ultimately going to be on the user interface thread, and so the database operations are going to block the user interface thread, and we might see some stuttering.
Yeah. But how were we going to solve that? Because we wanted it to be. Why did we know that all that? No, the purpose was to put all the database and the network communication on a background thread. Because anyway, on a mobile device, otherwise it's gonna be worse than it is today with my application. But okay. I will look back what I wrote down about it and check how we're gonna solve it. So this way, and then we had the Git changes. Yeah, that was all yours. All these changes, we're gonna add them also, and then merge into latest commit. Okay, everything committed.
Very good. Thank you, sir.
Now, I I haven't uploaded them yet.
Mhm.
I hope that all your tests are still, are still passing. Uh,
Yeah, so far
so
these are all your tests here. So
yeah.
yeah, I haven't run any tests using the SQLite provider. Um,
Mm-hmm.
so
Okay.
so the next thing that we're working on with the SQLite provider is turning a specification into a SQL query.
Yeah.
Um, so have you made any progress on that?
I've made progress in my mind, but not not in this this source code.
Mhm.
Um, so actually, when I started to write it down, then I run into that old code, and then I say, okay, now let's merge it, and
Mhm.
yeah, from one thing I run into the other. Um, some other things I run into was that a lot of for example, the interactive module
Mhm.
in where was it? Let me switch to the other screen. Stop this streaming and take the other one here. Um, that's the one here. We'll have to make that smaller, I guess.
Yes, yeah, that is impossible to read.
Is is this better?
Haven't seen a change yet.
It's just a small window now.
Yeah, it's not updating. Yeah, we might have to stop and start the
Um,
stream again.
oh, is there a refresh here? No.
Okay, it's just
Ah,
changed.
okay. Um, for example, if we go to interactive here,
Mm-hmm.
because you split the server, and
Yeah.
so here is pointing somewhere to the specification parser. I
Mm.
think it was that. And the specification parser comes from Jinaga now. So
Yes.
because you used it somewhere else,
Mm-hmm.
and the result is that this integration is, or this interactive is not working anymore.
Okay. Yeah,
Um,
I intended for it to be a temporary thing, so yeah, we
yeah,
should probably just go ahead and delete it now.
okay, because it's a nice tool to test. Um, but we could just refer this to wait, where were we using
Yeah. So yeah, this
this?
tool loaded um, a specification from a text file. Oh goodness. Biscuits is making a big mess over here. Um, yeah, so that was the intent. There was load a specification from a text file, which I
File,
believe is in
yeah,
docs, and then um,
it's this one, specification.txt.
yeah, and so now that we have the read endpoint, we can do all the testing using using that and Postman.
Postman. Yeah. Okay. So and then there was another somewhere where you were using absolute path, but I didn't write down where. Okay, I will find it again. So it was working on your side, but not on my side.
Mm. Okay.
And
Yep.
I changed it, but then I overrode it again. Was it somewhere here? Just in, no, it was not here. Never mind. Next time I encounter it, I will note it.
Okay.
Stop this one. So you were trying to align the specification language or the link syntax to
Yes.
use it for multiple platforms. But then you said that the link infrastructure is not available in
Yes. In
JavaScript.
JavaScript, that is correct.
Now I went looking, and there are a few libraries to use
Mm-hmm.
use link on JavaScript, but they are working completely different, or
Yeah, they use some tricks, and in fact, I ended up using very similar tricks. So what I have looks like Link, but because of those tricks, you have to do a little bit more work. Um, so I think I'm pretty happy with where it ended up. So I will do a share and show where that is. Okay, so we are looking at the code. All right. Okay, so yeah, if we take a look at the model here, this is a very uh, regular-looking model, similar to what we've seen in the past, except that it doesn't have any static specification functions. So basically, this is a replacement for that specification function syntax. So we don't have to return j.match and then a subset of the fact. Um, so we just describe the types with their predecessors and their fields as constructor parameters, um, and then um, we've we basically have all that type information in TypeScript, but it gets erased at runtime. So so we basically have to describe those relationships. Here are all the types in the model, and then here are all their predecessors, so we can build that graph for runtime. So this is the extra bit that you have to do uh, because JavaScript is a dynamic language. So here, just defining the type user. It doesn't have any predecessors, but username has a predecessor called user, and its type is user. So for all of these, I'm just using the class, and um, it's able to pull the static type property out of that class. So every type has to have a static type property in order for this to work.
yeah,
And then here it is looking at all of the TypeScript is looking at all the fields, so it's helping you out and saying, okay, you can only declare, you can only use those field names as the parameter here. Yeah, like for example, if I did dot predecessor, yeah, now it's got office type or user. Those are the only fields you've got. Um, and then, yeah, type is just a string, so that's not one of the predecessors. But then once you pick the predecessor, then TypeScript knows this is a fact constructor of type user. So the only valid fact constructor that you can pass in is actually user, and it validates that. So we're getting the help from TypeScript, but then we are building this model for runtime. And now that we have that model, we can do .given and say what is our starting point. Right now it only allows one starting point, but there's nothing about this syntax that limits us to that. I'll have a given overload that takes 2 or 3 type parameters. I've never found a use case that needs more than 2, So going up to 3 is probably sufficient for the library, but if I ever come up with a use case that needs more than that, then we'll go ahead and go up to 10. I don't know. I guess we could actually make it variadic, and then you could, yeah, you, I, yeah, I think you can do that. Okay, I'll make it variadic, so you can specify as many as you want. Okay, and so yeah, we have the given, and then we match, and now it knows, TypeScript knows that company is a label of type company. And then it gives us our fact repository. So this is just like in .NET. And so you've got facts of type office, and we're using this syntax, passing in the constructor as the parameter, as opposed to using this syntax, because generics are erased at runtime, and so we can't actually tell that it was a fact of type office when we're actually running it. So pass that in, and now we know that it's a fact of type office. And so now join gives us back a label of that type. So here's the label of type office. Company already came in as a label of type company. So that means on the left-hand side of the join, I can use the brand new label, but on the right-hand side of the join, I have to use existing labels, things that I already know about. So that's why the left-hand side takes a lambda, but the right-hand side, you just pass in labels. So far, it is, for a very simple successor join like this, it is now producing the specification structure. It is not using the names that you gave to these variables. So in .NET, it's able to get these variable names because it has the expression tree syntax. But in JavaScript, it doesn't have access to those names. And in fact, as you minify, those names will probably get changed to other things anyway. So instead,
that's why it becomes P1, U1.
Yep. So it's just parameter and unknown.
Yeah. Which is not too bad because the type is there. So.
Yep. So yeah, practically speaking, that's not going to make a difference, because this structure is then used internally to do things like compute inverses, to split the specification into feeds, to run the specification and get the current projection. And so all of those things can operate just on abstract identifiers and the computer. Yeah, the compiler doesn't get confused, or the runtime doesn't get confused. The only time that it would make a difference is when a human wants to take a look at this specification. So so I haven't yet done it, but specification of unknown. That's not right. Okay, yeah, I still need to work on that part. But so that should get me back to a specification of observable office. Specification of observable of office, I think, is what I'm going for there.
Yeah.
Wait, no, the specification already implies the observable. It's that you just need the observable in the projections. So this should just be specification of office. But yeah, so doing a little bit of trickery here in order to make the tests easier to read. So I start toDescriptive string at depth 2. That way I can have this string indented and not have it sticking out to the side like I do in the .NET tests. And then rather than put this on the first line, I said, okay, let's go ahead and insert that new line, but then I have to put that into yeah, I have to put that into the actual call to descriptor string so that it matches that. And then this other one, it actually puts a new line at the end, but I don't want to have that hanging out way over there. So it's like, okay, let's put that one at the end. So just to make the tests easier to read. But yeah, that's the kind of thing that that we currently have to do, since we don't have type information and we don't have expression trees.
Yeah. Okay.
But not too bad. In fact, some of the other libraries that emulate LINQ, they use similar tricks, and they end up looking pretty similar to that.
There's none of them which implements expression trees.
No, no, because that is a compiler idea. The .NET compiler, whenever you have a function that takes an I or an expression of something, then the compiler knows, okay, let's actually turn that code into an expression tree. So at runtime, you've got that object. But yeah, there is no such thing in TypeScript, and yeah, JavaScript doesn't have a. Yeah, in JavaScript you can pass a function. So in fact, like here, I'm passing a function in, and you can look at certain properties of the function. But yeah, for JavaScript to support expression trees, basically you would have to be able to look at the body of the function, and it doesn't expose that. It gives you the arguments. It gives you a way to execute the function. It gives you a way to bind it to set the this pointer to whatever you want it to be. But yeah, it doesn't give you a way to just iterate through the body of the function. And that's ultimately what I would need to do this the expression tree way.
In fact, the only thing we have to do additional is describe the model structure.
Yes.
Yeah.
Yep. Yeah, and so far I've only had the need to describe the predecessors, not the fields. I want to avoid describing the fields because that should be selectable dynamically at runtime. So, like here, yeah, I commented these out because I was working on the type system. I said, okay, I don't want to have to force this to keep compiling. Let's go ahead and comment those out. But yeah, you should be able to do something like this, where after you've done that join, I want to select, basically project each office into a JavaScript object that has its identifier being equal to the office.identifier, and so that's a string. And so it can tell that at runtime because it's got the actual fact at the time that it's trying to produce that projection. So it should just, if that fact is, if that ends up being undefined, okay, I'll just set the identifier here to undefined. If that identifier ends up being a number, okay, fine, I'll just set that identifier to a number. Let it be dynamic for the fields, but for the predecessors, it needed to actually do some extra work.
Okay.
Yep. So this is an example of how a more complicated specification would look. And this is probably starting to get kind of realistic. You would end up with these kinds of specifications in your code. and this is probably just before I would want to start breaking it apart and saying, okay, I'm going to extract this and make that its own function so that I can reuse um, that collection or that part of the specification. Um, but yeah, so you end up with these nested. So we've got for the president, I want all the facts of type president. Join that back to the office, which was a label that came in here, and not the label that came in here. And so as you go deeper and deeper into these arrow functions, you've got more and more labels at your disposal, and you can join to them. Which raises a very interesting distinction between what this syntax is going to end up looking like and what it produces here. Here in this syntax, you can define another, like it would be U2 is a president, and U2 office is equal to U1. So you can do that in this specification language.
Yeah.
It means something different. Here we are actually getting presidents as a collection in each office. So I hear ya. But in this case, we are getting a tuple of every office president combination. So it means something different. But if that's what you mean, then the way that you need to express that is there would be a select many. And so select many will bring the office label in, and then I can do facts of type president to get the president label. And then I would be able to produce a tuple that has both office and president, and that's my many. That's the output of the select many. So haven't written that syntax yet, but that's what we'll end up having to do. And so it'll be dot select many every time you want to add one of those, and then the parameter list will grow with each one of those.
Okay.
So, which actually is how it looks in .NET if you use the extension methods. But doing all that in .NET with the keywords ends up looking just like this. You just say from office in facts of type office, from president in facts of type president, and you just keep on going in a line. So .NET has a really nice, succinct query syntax, but this is as close as we're going to be able to get.
So for JavaScript, we keep to the extension syntax.
Yeah. Move your tail. There you go. Yes. Yeah,
what
we don't have the
Biscuit is
actual...
doing.
Yep, he was trying to get out. So it's like, okay, go play with your brother.
Oh, there are more cats.
Oh yes, yeah. Dumpling is the one that you don't see. He doesn't like to get on the stream. But yeah, Biscuits and Dumpling.
Okay.
Yeah. So let me get this back to something that works.
I was surprised. I was surprised you came up with a new syntax in this state of the project. But I think after all, it's a good thing.
Yeah.
As somebody who will have to work in both languages, in JavaScript and .NET, it will otherwise be more confusing.
Yeah, and the reason that I decided to do it now is that the very next thing that I'm going to be working on is the query inverse. So basically, this is all getting ready for the Jinaga experiment. So I want to I went to get Jinaga.js ready for React Native, and
Yeah.
then in the Jinaga experiment, I want to hire people to write React components and React Native components. Um,
Mm-hmm.
in fact, I might actually just stick with React Native, and then when I want to use them on the web, I'll actually use React Native to compile to the web, which is a thing, and it's kind of weird that you can do that. Um, but um, but yeah, so in order to get that ready, um, I want to address some of the issues that have come up in Jinaga.js, and one of those is that the query inverse is incorrect, and it misses some cases, um, and so I would really like to have that fixed. And then while running the experiment, if I have to teach people the specification function syntax, then I'm not collecting the data around how easy is it to learn this syntax.
Yeah.
So I think ultimately um, I want to just go ahead and start the experiment with this syntax in place.
Okay. Um, but for the inverter, um,
Yeah,
what was the issue with the old syntax?
yeah. So yeah, yeah. I think I can stop sharing. I don't think there's anything here to demonstrate that. Oops, wrong button. There we go. Uh, Stop streaming. No, don't turn off the camera. All right.
Close.
Um, so um, the the big issue was that um, when you when you have that linear pipeline, then as soon as it starts to branch, the inverse makes some assumptions that turn out to be incorrect in different scenarios. So, for example, if you were to have a where not exists, and then a second where not exists within that clause. So, which happens quite a lot. I want to show all of the um, all the items that have not been deleted, such that those have not been restored. So so you get that pattern happening all the time. So in that scenario, it would assume that restore will always bring the object back. But if it was deleted in parallel, if it was deleted twice, then this restore makes this delete go away, but doesn't make the other delete go away. So it should still not be in the result set. So um, so there were edge cases like that where just clicking through real fast and showing, hey, it's doing conflict resolution, and then restore, and it pops back up, and it's like, but it didn't pop up over here. Um, so it's uh, the the inverse mechanism that this syntax supports, that this structure supports. I have actually been able to work through that proof on paper and say, yes, this satisfies the conditions. It always gives us back a consistent result, no matter how um, you inserted those facts.
Okay, so all the edge cases are proven to work correctly.
Yes. Yep. So I think that's going to be pretty important when
Mm.
shipping this out. Um, yeah, I've been looking at kind of the competitive landscape again, as I often do. So, um, so the big competitor right now that I am weighing Jinaga against is Firebase, and um, and so I'm seeing a lot of people saying Firebase does all this awesome stuff, and it does. It does a lot more than I want Jinaga to do. Um, and then every once in a while, I'll see somebody complaining that Firebase doesn't scale to the the problem that they're trying to solve, um, and that's in two ways. It doesn't scale uh, to the size that they want it to be, um, and it doesn't scale to the complexity that they need. And so that has to do with the way that that Firebase um, handles uh, these branching relationships. Firebase is a very hierarchical. Uh, it's basically a JavaScript object in the cloud, and then you can carve out a subset of that JavaScript object, which means that you're getting information that's in this part of the tree. But if you've got a relationship that points to another part of the tree, then you have to get that ID out of this query, go back to that other part, find that ID over there, and then do all of that connecting up yourself. And so I've seen people say, okay, once I've scaled the complexity past the to-do list example, then it gets really difficult to make something work. Um, and so I want to be able to say with a straight face, when you write this specification, it will work. It will scale to the complexity that you need. It will be able to solve any problem that you can specify in this specification language.
Okay.
Yeah, and if I get that wrong on the first release, I don't think there's going to be a second chance.
It must work correctly, because otherwise people will say, okay, it's random.
Yeah.
Um,
It's like, all right, math boy, you said this was based on CRDTs, but why don't I have eventual consistency?
it's it's based on math with a random factor in it.
Yeah.
Oh, good. That looks promising that way.
Yep. Yeah, and what that syntax is doing behind the covers is actually building the same specification object that that the parser produces. So and I'm also building up the toDescriptor string of that object, and never needed to turn it into text before, and so that means that once it's in that format, I can port the query inverse function from .NET into JavaScript, have that working there, and the JavaScript client will be able to call the JavaScript server using these new endpoints. So everything will just shift over to that structure.
But so you get the same specification object.
Yep.
From which we generate the SQL then.
Yep. Exactly.
Okay.
Exactly. So yeah, this would be able to just run run a query just like the read endpoint does, and give you back a projection, and it'll be able to produce feeds and walk bookmarks over those feeds. So yeah, using all the same structure.
That's nice. Now, one of the things I was still running into when I went again over the documentation and the README files was also the definitions. Like, for example, a tuple, there was some, I think I wrote it down. Let me see. It was in the specification text somewhere. Product, what is the... Yeah, I don't see it immediately, but another one here. Ah, yeah. Yeah, there are two. in the text, often you speak about labels,
Mm-hmm.
and often you speak about facts. But in
Yeah.
fact they are the same. Or am I wrong there?
Uh, there is a subtle difference. It's kind of like a label is a variable, and a fact is a reference. So um, a label can take on any value. The label exists even before you point it at a very specific um, snapshot of a graph. Um, but then the fact reference is a very specific instance of a fact.
Like a label is in fact a placeholder then
Yeah, yeah,
for the facts that. Okay.
yep.
Um,
But yeah, on the tuple versus product, I don't think that there's any value in keeping that distinction around. So I might collapse that into just
yeah.
one name. And I think product is the name I want to choose there, because it calls to mind Cartesian product, and that's precisely what it is. Is that you've got all of these different constraints of how these labels are related to one another, and so it finds the facts that meet those constraints, and then it gives you the Cartesian product of that
Mhm.
set.
And there was another one here. Specification. Specification paper. Which was that? I think that's. They wrote path is a pair of labels and a sequence of roles leading to a common ancestor.
Hmm. Yeah,
Um,
that is a very wordy way of saying that. um,
and then what I think it is just a linear chain, is it?
um, yeah. So given a graph, so let's talk about the fact type graph. Um, so you don't have the actual fact instances in the graph; you just have the types and
Yeah.
all of their predecessor roles and the types that those refer to. Um, so that's basically the graph you end up with when you're finished with that model section, where you say, "Hey, there's this type and it has these predecessors. That type has these predecessors." That graph.
Yeah.
Um, then you can label different points within that graph. A path um, is um, it is a way to get from one label to another, but it's constrained. It can't just be any way that you can follow those edges to get from one label to another. It has to go upward from both sides. Um, so it can be up from just one side until it hits the other one. It can be up from the other side until it hits the other one, or it can be up from both of them until it hits a common ancestor. So it has to go up and then back down, and that is a valid path.
Okay, so I was thinking you have a specific type, you go to the predecessor, and then you go to the next predecessor, and then that is a path. But the fact that you say common ancestor is because you want to go up and you want to go down.
Right.
So you have uh, both types which go to a common ancestor.
Yes.
Okay.
Yes.
I find a lot of these descriptions, if there would just be a little drawing next to
Yeah.
it, would make it a lot easier. Um,
Yeah. Yeah. That's a good idea.
because it's like a definition, but then I say, okay, what is it exactly here?
Mm-hmm.
Um,
Yeah. And the thing with path is when you're in code and you're actually creating a path, it's obvious that that's the only thing you can create, because you've got two sides of an equal sign, and you've got a label, a variable on each side, and then you can say dot predecessor, dot predecessor. So
hmm,
that's the only thing you can do is put a common ancestor on each side of the equal sign with a bunch of edges up to their predecessors. It just so happens that that also proves that that you have labeled all of the valleys. Um, you can't go down and then back up, and therefore you don't have a label in the valley. Um, you have to put a label on that in order to be able to reach up to the others. So and the first optimization that I do in the book is to eliminate the middles or the common ancestors, eliminate the peaks, and say
Yeah.
if you focus only on the valleys, you get everything that you need. You don't need the others.
The others gave no result, but because there were no predecessors yet in the graph.
Exactly. Yeah.
No successors yet.
Yep.
Yeah.
Yep. Exactly.
Mm. Yeah, but it's actually the document is to understand the code.
Mm-hmm.
And it's very well written, but left and right on the details, I say, what is he meaning here? And I think with just a small drawing there, that would, but okay. Making a drawing is, if it has to be nice in a document, it takes time.
Yeah, not too much time though.
But it would be, I think, if ever there would be a comprehensive documentation on the internal workings of Jinaga, it would be nice to do that
Yeah.
way.
Yeah, I
Like
think
you
so.
did in the book.
Right. Yeah.
Like you did in the book.
Yeah. 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 And I want that kind of a description for the math paper too. Maybe the math paper can get more symbolic and more abstract, and people will be fine with that because it's a math paper. But yeah, having some drawings in there so you can understand what the symbols mean. Nothing wrong with that.
It can be abstract as long as the definitions are very clear.
Yep. Yeah, that's the one thing that is missing from a lot of math papers that I read is the intent. Why did you write the equation this way? I was like, well, we just take this to be the definition, and then manipulate. We get this result. Say, oh, okay. Now I have to understand each manipulation in order to understand the intent. And so, oh, that's why you made that choice. So that's a nice little surprise if that's what you're looking for, is a nice little M. Night Shyamalan plot twist in the math paper. But if you just want to read it for understanding, give me the intent.
The one who wrote to the math paper has been working and thinking about whole life.
Yeah.
And the one who reads it just wants to understand it. That's a different story, I think.
Yep.
Okay,
yeah. Let's introduce this lemma. Okay, what's all right, sure, I see that lemma is true, but why? Oh, because way down here we use it, and it's like, ooh, magic. Okay, motivated. Anyway.
if we introduce that, then everything turns out to be working.
Yeah.
Okay. I think that were the main things that I wrote down here. Okay.
Excellent. All right. So I took notes, and so I will. In fact, in previous notes, I do have some other things that that I want to change about the documentation, specifically around Docker, I believe it was. So yeah, I got those notes. So yeah, those changes are on the list.
And yeah, perhaps also bring all the documentation together, because often when you walk through the source code, you see, oh, another markdown file.
Yeah.
Click. Oh yeah, remember.
Yeah.
So perhaps we should in the source code just have one folder called doc, and have all the documentation there.
Yeah, I think there are two of them. Yeah.
Yeah. Now it's a little bit everywhere, and sometimes it must be me. My memory is so short.
Nope, nope, not just you. That is human.
Okay, so next week it will be back on which time?
Yeah. So next week it will be. I should be. Oh, mhm. I think it's going to be 1400 UTC because we're currently at 1300.
Yeah,
So
uh,
math is
it will
yeah.
it will it will shift 1 hour. It will stay on the same time in your region. Is
Yes.
that
Yeah.
correct?
Yes.
And you go to winter hour.
Yeah.
Okay.
Because I still have to get to work at the same time, and so
Okay.
yeah.
No, that's perfect. Um, if in doubt, I will just check once an hour.
Okay. Yeah, and I'll update the calendar as well. So
Yeah, but I don't
yeah.
usually I don't look to the calendar.
Hmm.
So okay, Michael, see you next week.
Very good. See you then, Jan.
Okay, bye bye.
Bye.